This is Lalita, your host for Mushrooms on Mars. Today, episode 3, we are going to talk about closed loop systems and the need for closed loop systems in space. So, what is a closed loop system? It simply means it is a self-sustaining cycle in which resources such as water, air, and nutrients, etc., are continuously recycled and reused with minimal waste. The hydroponic way of growing plants, the aquaponic way of growing plants, these are all closed loop systems that already exist that we use here on Earth. But this becomes really important in space because there, in a constrained environment, we don't have access to resources and we have to rely on resupply missions from Earth to bring us the resources necessary. Now, it's not just the cost, but also the logistics of bringing everything we need from Earth on Mars or space habitats or lunar colonies. It's not feasible. So while we will still need to bring some resources from Earth, at least in the beginning, we can minimize waste. We can reuse and recycle the resources that we already have so that we are not reliant on resupply missions. So we're basically looking at air regeneration, which means carbon dioxide and oxygen management, air exchange, that is important. So we breathe, plants breathe, right? So we take in oxygen, we give out carbon dioxide, and the plants take in carbon dioxide and they give out oxygen. So there's an exchange here. Now that needs to be managed, okay? And then there is water purification and recycling. Plants need water, we need water, but we also expel water through sweat, through urine, through our body waste. Gross, I know, but still we expel them, and that is needed for the plants. So there has to be a purification system, and where we process our waste and our liquids so that it can be used to hydrate the plants. So once again, that becomes part of the closed loop system. So waste recycling, water purification, air exchange and air regeneration, these are all parts of the closed loop system. So there is a partial closed loop system already existing in ISS. The goal is to create a complete closed loop system with our space mission, current space mission. So ISS is equipped with a partial closed loop system where they recycle the water and they remove CO2 from the carbon dioxide from the atmosphere, but they still rely on resupply missions. So, and the reason we are bringing this up for Mushrooms on Mars, and we haven't even gotten to mushrooms or Mars, but it is important to understand these concepts. It is important to understand how plants grow, and mushrooms are not plants, they are mycelium. How plants grow, what have we already done in that area, and also what are the challenges and restrictions, and what have we achieved so far with plants. And it is important to understand that. And we have to find a way where mushrooms can be used in this system, in this closed loop system, so that it kind of fits in with the full picture. Our presence in space, our needs and the challenges, and also what have we done so far. So first we have to know what we have achieved. What are the experiments that we have conducted? Where did we fail? What is working and what is not? And that is why before delving deep into Mushrooms on Mars, we are spending time on plant growth systems and closed loop systems. So let's move on to the deep dive right now, and we will see We will see where this goes.
Okay, so let's dive into the scenario, right? You're about to blast off on a one-way trip to Mars. What's the absolute one thing you cannot forget to pack?
That's a good question.
Yeah.
I mean, I'd have to say oxygen, probably. You can't survive on Mars without it, right?
Okay, good point. But you know me, always thinking about the practical stuff. I'm talking about food. You got to eat on Mars, but packing enough for years and years, that's just not going to happen. So how do we even begin to tackle the challenge of like feeding a whole Martian colony?
Right, yeah, that's the million-dollar question. Shipping supplies back and forth is just not sustainable, especially that far out.
Exactly. That's where things get really wild because the solution is like something out of science fiction. We're talking about closed loop systems.
Yeah, closed-loop systems. So these things are basically all about mimicking the way nature recycles, just, supercharged.
Okay, walk me through that. How do you create a closed loop in like the middle of space?
Well, the basic idea is that every single output, and I mean everything, even things like wastewater,
Wait, you mean?
yeah, even that gets turned back into a valuable input. Nothing is wasted.
So we're talking about turning, into like drinkable water.
Exactly. And it's not just about water. Think about a mission to Mars, right? Every single resource is precious because getting more is just not feasible.
It'd be like, I don't know, trying to drive across the country on a single tank of gas not happening.
Exactly. Closed-loop systems for a mission like that aren't just efficient, they're the difference between life and death.
Wow. So we're not just talking about sustainability, we're talking about survival.
Exactly. We need to create environments that can sustain themselves.
So how do you actually make this whole self-sustaining thing actually work, in space?
It does sound pretty futuristic,
Yeah.
right? Like something straight out of Star Trek.
Right.
But it's based on solid science. We're already doing it, in fact.
Wait, really?
Yeah. Remember when we were talking about wastewater?
Oh, yeah.
The International Space Station actually has a system that purifies it
You mean they take,
and turn it into drinkable water. Yep.
No way.
Yeah, the water recovery system they have up there can recycle almost all the water they use.
Wow. I guess every drop counts when you're up in space.
Absolutely. It's all about minimizing waste, and that's where things get really interconnected. Yep.
Okay, I'm intrigued. What do you mean?
Well, think about something like carbon dioxide. We breathe it out, right? And here on Earth, plants use it.
Photosynthesis. Yeah, I remember learning about that.
Exactly.
Yeah.
And it's the same principle in space, but even more important.
Because you're in like a sealed environment.
Exactly. You can't just keep pumping in fresh air. So what they can do is use the CO2 the astronauts breathe out.
Wait, seriously, what do they do with it?
They can feed it into bioreactors.
Bioreactors, what are those? Like high-tech trash cans?
Not quite. They're more like tanks.
Mm-hmm.
And they've got algae and other microorganisms growing in them.
Okay.
And they consume that CO2 and release oxygen. Plus, they can even create food and other useful stuff.
Whoa. So it's like a whole mini ecosystem just going on inside spaceship.
That's really cool.
Oh.
And if they can do that in space, imagine what we could do with that kind of technology back here on Earth.
Right. The possibilities are huge. But for now, let's talk more about space. We've got the air and water figured out. But what about actual food? Like on a Martian base? Would astronauts be stuck eating those freeze-dried ice cream sandwiches forever?
Well, I'm sure they'd get tired of that eventually. But actually, there's been some pretty amazing progress.
Really? Like what?
The International Space Station has actually had some success growing food. They've grown lettuce, radishes, even some flowering plants.
Wait, flowers? In space?
Yeah, it's not just about having something pretty to look at either, although I'm sure that helps.
Yeah, I bet.
Fresh produce has tons of essential vitamins and nutrients, which is hard to replicate with those prepackaged meals.
Right. Yeah, you can't survive on Tang alone.
Exactly. And even more importantly, just having something green and growing can really help with mental well-being, especially on those long isolated missions.
That makes a lot of sense, a little piece of home. So are there some plants that are better suited than others to be grown in space?
Actually, you might be surprised to hear that mushrooms and algae are ideal for this.
Mushrooms, like the things you find growing on logs.
Yeah, they're great in controlled environments, and they can even be grown on organic waste. Plus, they're super nutritious.
Wow, mushrooms. Who knew? What makes them such good candidates?
Well, for one, they're really good at converting waste into edible food.
Oh, interesting.
And they don't even need sunlight to grow. They use something called chemosynthesis instead. Some of them can even break down toxins.
So not only are they a food source, but they could actually help clean up a closed-loop system.
That's the idea. They may be small, but they've got a big role to play in the future of space exploration.
Okay, so we've got our Martian base, right? Our closed-loop system is humming along, recycling everything, even growing mushrooms. But there's one tiny little detail we haven't really talked about. Gravity. Or rather, the lack of it. Here on Earth, we just kind of take it for granted. But in space, how do you even farm without gravity?
That's a big one. Plants have spent millions of years adapting to Earth's gravity, so figuring out how to grow things in microgravity, that's a huge challenge.
So no more just planting seeds in the ground. What's the alternative?
Think a little more high-tech. Hydroponics is one way to do it.
Hydroponics.
Yeah, instead of soil, the plants grow in a nutrient-rich water solution.
Like those trendy vertical gardens everyone's growing lettuce in these days.
Kind of, but imagine it on a much bigger scale. Vertical farms with LED lights, roots just soaking up everything they need from the water.
Very cool. What about aeroponics? I've heard that one too.
With aeroponics, you're taking it a step further. The roots are actually suspended in the air and misted with that nutrient solution.
So even less water than hydroponics.
Exactly. And it gives you amazing control over the growing conditions.
It's like we're tricking these plants into thinking they're at a spa, not on a spaceship millions of miles away. But even with all that, we still haven't solved the whole no gravity thing, have we?
We haven't. That's why some scientists are looking into things like rotating habitats.
Rotating habitats, how would that even...
Basically, you create centrifugal force by spinning the habitat, and that outward force acts like gravity.
So picture a giant spinning cylinder, and the plants inside are basically tricked into growing normally.
Exactly.
Mind-blowing. Now, I have to circle back to something you said earlier because I can't get it out of my head. You said something about building structures on Mars using mushrooms.
Yes. Myco-architecture.
I have to admit, that sounds a little crazy.
It does, but it has huge potential. Remember how we were talking about the amazing properties of mushrooms?
Yeah, they can grow on almost anything, clean up toxins, the whole 9 yards.
Right. Well, their root structure, called mycelium, is incredibly strong and can actually be used as a building material.
Hold on, we're talking about literally growing buildings out of mushrooms.
In a way, yes. You can grow mycelium in molds, and it binds together to create these strong, lightweight structures. And they're fire-resistant, too.
Wow. So instead of loading up a spaceship with tons of building materials, we could just bring like a bag of mushroom spore.
Exactly. You could land on Mars and essentially grow your habitat right there using local resources.
Incredible. It really drives home the point that the future of space exploration isn't just about rockets and technology. It's about working with nature.
It is. It's about taking inspiration from the natural world and applying it to these new challenges. And who knows what other incredible discoveries await us as we continue to explore.
This whole conversation has been mind-blowing. From recycling wastewater to building houses out of mushrooms, the future of space exploration is looking pretty amazing.
It really is an exciting time to be looking up.
Absolutely. Well, thanks for joining us for this incredible deep dive into the world of closed-loop systems and space agriculture. And to all our listeners, keep looking up and stay curious.
How was it? So we discussed how the closed loop system is important. It is critical. It's critical to the future of space exploration and long duration missions. What it does is it enables the recycling of waste into valuable resources like oxygen, water, food, etc. Growing plants and other organisms in these systems not only provides like fresh food, but it also converts, the most important thing is it converts CO2 into oxygen. So it is critical, it's important that we have a system that grows plants on our space missions, in our space habitats, or in any of the colonies that we might set up. In the upcoming episode, the fourth one, we will go deeper into what kind of closed loop system exists on ISS. So International Space Station already has a partial closed loop system that works. It is not yet a fully developed closed loop system, but it contains several critical components that aim to recycle the water, the oxygen, and the waste. And then what they want to minimize their reliance on resupply missions from Earth. So it's like a test bed, you know. So that's what we will be looking at in the next episode. Until then, goodbye.